Alright, we're out here by the forge. Calvin, wave to the camera. This is pretty simple setup. Calvin's going to walk us through it. Why don't you go ahead and tell us about the design, what this actually is, what we're looking at.
This is a forge. And basically what it is, it's a walk with legs and a pipe coming out of the bottom. That's it. It's not much more complicated than that. Here we have, like I said, the walk pipe. We riveted some legs down to here to the bottom. We have a pipe bolted into the bottom with a flange, which comes down here, which is crudely taped onto this air duct, where we use our air supply, which is a leaf blower, an electric leaf blower, not a gas-powered one. So,
seems like a pretty crude setup. How complicated does a forge need to be?
Incredibly simple. All it needs to be is good source of fuel, coal, which is what we use, or charcoal. You know, we'll explain the difference later. Good fuel source and air source. Basically, that's it. In order for a fire to get hot enough, it needs enough air to fuel the fire. Yeah, that is our forge. Very simple. And over here we have our anvil and an example of our fuel source. This is a big giant-ass lump of coal. If you've been a bad boy this year, you're familiar with that.
Actually, blacksmiths want coal under the Christmas tree.
Oh,
so tell what's this little interesting piece right here? This guy. What's the difference?
This is our a rail anvil. This is a high carbon hunk of steel. High carbon as in it's just hard. That's all you really need to know about it. And it's better. It's better than this anvil in the sense that it doesn't absorb blows as well. This anvil is mostly iron, not very much carbon in it at all.
It's a sand-casted iron. It's
sand-casted, so it does not have rather than it absorbs a lot of the blows rather than deflecting the force.
So why are we using this one instead of this one today?
This one we're using because we have a much bigger project. I can show you. This is the workings of a machete. It's a long. We are amateur blacksmiths. This is something that a real blacksmith could probably do in a few hours. This is what. Well, in a few minutes. This is what we did in a few hours.
Well, we don't actually have the big pneumatic hammers. We're doing everything by hand.
Yeah, absolutely. So this is a long, ongoing.
So why don't you go ahead and show us the other side of that? What did it look like beforehand?
Right here.
So
we actually worked this end, but we had messed it up and decided to start over.
So let me see the other end. Now we did. This is our first project, wasn't it?
Yeah.
So why don't you go to the other side and show them the other side? The other side of the billet.
Mm-hmm.
So, as you can see, it's much more uniform and it's starting to take shape. Keeping in mind that only about one afternoon went into work on this. And this is a car spring, very thick, very heavy, and it requires a lot of force to get it to move any kind of into any kind of shape. And so we used a sledgehammer for that, as opposed to a small claw hammer, which you'll see right there, because these spring steel billets fight back. So in one afternoon of work, we actually got the head of the machete already started. Alright, so if you come down here real quick, we'll take a quick gander at this. So this is coal, this is charcoal. Now, the obvious difference is the size. First and foremost, you'll see that. Alright, so we talked real quickly about the coal, but there's also another brand out there called charcoal. Now, the immediate difference is the size. This is actually just a giant rock that we pluck from the ground, whereas this little guy right here is actually manufactured to look this way. This is actually wood that's been mulched and burned to be this nice kind of smooth black surface. This is much easier to start than this is. So you start off with wood coal. Now if you want to remember the names of these two, it's charcoal and just coal. Charcoal because of wood char, and it resembles coal, so char coal, keeping in mind that this has not been charred. Now, if you take a look here, we have these very granulated, minute pieces. And believe it or not, these are the same as this. This right here is very smooth and slick, whereas this right here, as you can hear, it crackles a lot. It's very dry. It's basically a metamorphosized version of this. When you burn out all the impurities in this, you are left with a dry version. The reason this is slick is because of slag metal. This is called coke, and this is called coal. The difference is the purity. This is almost pure carbon. It burns very clean compared to this, whereas you can see in here we have pockets of sulfur. Now, these sulfurous pockets need to be burned out before you start forging, because it looks like a giant black cloud of smoke shooting out. But if you heat up your billet enough, you will actually put all the impurities in the coal into the billet. So what you want to do is get this burning nice and hot, and so it turns into coke. Now, you may be wondering about the impurities that are in the coal. They don't just disappear. They actually collect at the bottom and create something called clinker. Now, if you take a look at this, it almost looks like it almost looks a bit glassy on the surface. This is actually all junk metal and sulfur and all the crud that gets built up in the bottom of this. Basically, it looks like a big donut when you're done.
In our forge.
In our forge and a lot of forges.
Mm-hmm.
But it pools to the bottom. This clinker right here can sap your heat because you have all your coal and all your fire built up. And when the clinker is at the bottom of the fire, remember this is metal, and metal's an extremely good heat conductor. It pulls the heat into the clinker. Now, this may seem like a reason to get rid of all your clinker. But if you get rid of all your clinker, well, let's just say this acts as a bit of a glue. It holds your forge fuel together. And so if you put your billet in, it doesn't all go flying away. This is very, very light, and we have a fairly powerful airflow. So when you lose what holds it together, your fuel becomes airborne, and it's very, very hard to forge with it. So it's about getting the right amount of this. How do you know what the right amount is? There's really no science to it. You'll know when your billet doesn't heat up that you have too much, and you'll know when your crap's blowing all over the place like it's a hurricane is when you have too little.
Mm-hmm.
It's actually not hard it's not hard to keep in check, one way or another. And Calvin talked about airflow. As you'll see at the bottom of this, I've jerry-rigged, and you can come down here, I've jerry-rigged a crowbar under a flat piece of slate. We used to have like a gauge under here that actually just locked in and held it. But the problem with that kind of method is it pushes all the air up. Now, you may be thinking, well, that'd be a good idea. You know, we just said more air, more fire. Sometimes fire does not equal heat. It's a hard concept to get your mind around, but you can actually blow the heat out of the forge. You want it all relatively close to the center. And so if you have too much airflow and not enough pressure, you will blow your heat out the top. If you have too much pressure and not enough airflow, you'll get one spot about the size of a chicken McNugget that's flaming hot. So you have to get a right balance. And what you do is by leaving this slightly open, the pressure will push excess air out from under this. It actually regulates itself. So it's a lot better than just clogging up the bottom of it.
We did this because we have a leaf blower. It's a fairly powerful air source.